Well, good afternoon and welcome to our second talk of this session. Please help me welcome Susan Tan, who works at Cisco, for her talk, Let's Read the Code, the Request Library. Thank you.
Hi. All right. I'm Susan. I've lived and worked in California for the past 4 years. So I used to work at a small cloud computing startup called Piston, and then last summer they got acquired by Cisco. So now technically I work for Cisco in San Francisco, California. All right. The first time you open a new code base, let's say you're a new engineer at a new workplace, or you're a new contributor for a new open source project, you might run into a code base with lots of files, like hundreds, thousands of files. And it may be pretty difficult and daunting at first to look at this really large, unfamiliar code base and understand what's going on and how all the big pieces fit together. Navigating a code base carries this assumption that, well, if you don't understand what this code is doing, then, well, it's probably way over your head and it's too difficult. But I want to demystify the process of reading a new and unfamiliar code base. And especially, I wanted to look at the Python request library as a case study for looking, for reading it through, and we'll understand a lot of big chunks of this Python request library. We spend a lot more time reading code than writing code. And so I want to share some of my strategies that have worked for me on how to read a new code base. And we'll look at different parts of the Python request code base and really understand how certain methods are implemented underneath the hood. So the first step is to prepare your editor. So for any editor of your choice, you have to set up your editor such that you can jump into any method or class definition when you're highlighting it or when you're clicking on it. You also need to set up your editor so you can search files by keyword. And optionally, you may also want to see the call hierarchy of any given class or method. The next step, you should clone the repository, in this case, Kenneth Reed's request library. And then you open the repository. In this case, I'm using Sublime Text, and now you have the code repository in front of you. Then you can set up your local dev environment to get into the mindset of what it's like to edit the code. So in this case, you would create a new Python virtual environment, pip install the dependencies, run all of unit tests and functional tests, and confirm that they all pass. This is directly the screenshot from the official request documentation and how to set up the local working environment for making contributions to the request library. More often than not, the reason why you're reading code in the first place is that you want to get familiar with the code base enough such that you can make changes and edits to the code base. So setting up the development environment is a big step in that. So if you follow these instructions for setting up the request library, it would take about 5 minutes to do, which is, I think, it's pretty extraordinary. The request library happens to be on permanent feature freeze, so a lot of the features that it currently has now won't change much later in the future, and you can't really add new features to the request library. All right, so you have your editor set up, you have your local dev environment set up, you can now start reading the code base. And I like to think of reading code base as kind of like playing a game of Pac-Man. Sometimes the dots lead to a pretty clear logical direction. Sometimes you hit a wall and you have to retrace your steps and go into a different direction and try again until you figure out what this code is doing. When you Google search Python request library, one of the first results you'll see is the official request documentation page, and on that front page is this code snippet that does a GET request is being made, and you have a response, and then you can check the different attributes of that response, labeled like letter R. This includes the status code, headers, encoding, text, JSON response. So the goal for today is, in the next 20 or so minutes, we'll figure out how this code snippet works underneath the hood. So let's look at the unit tests for the request library. And all of the tests are located in testrequest.py. There's over 1,600 lines of code here. And let's narrow down the range of things to look at. So let's do a get grep or keyword search on request.get and see what we get. there's over 40 instances of the unit test that mention request.get. So let's just look at one test and focus our efforts on that. So I've picked this test, test digest, http 200 OK get. So I'm going to go over each section of this. So in the first section here, there's some test setup that's happening. The auth object gets created, a http digest auth instance is being invoked with the strings user and pass, and then there's a URL object or variable that gets created with the httpbin method. In the next section here, you can see that there's two requests that are being made, one with the auth object and one without the auth object. When you have the auth object, you can access the page. It's a 200 response. Without the auth object, you can't access the page, and instead you get a 401 forbidden error. So this says that you need to have some sort of correct authentication credentials in order to access this URL. Then in this third test here, you can see that there's a session instance that gets created, and then the auth attribute of the session gets populated. The get method gets invoked on a session, and you can access the page. So there's a number of questions. When I'm first reading this code for the very first time, some of the questions I have is like, what is this sessions thing that's happening? What is this HTTP digest auth? And what is this HTTP bin? So I'm going to answer and figure out the answers to all of these questions. So let's look at the first thing. So there's HTTP digest auth. It takes in a user and a pass as strings. Let's do the function jump and look at the class definition of HTTP digest auth. There's a number of methods here, and I'm going to ignore most of them except for the init method. And the init method takes in the username and password, which are the required arguments to create an instance of HTTP digest auth. Let's look more in detail about what is this digest auth. So the digest auth is a very popular form of HTTP authentication, and it's supported by the request library out of the box. And this is directly from the documentation. You can see in the screenshot code snippet here that the GET request is being made, and that line looks really similar to what you just saw in a unit test, where an auth object gets passed and the auth instance gets created. All right, so we have a pretty good understanding about what HTTP digest auth is doing, and we have the auth object all set up. Next, let's look at the httpbin method and see how that's defined. This is the definition of the httpbin method located in conftest.py. And if you're familiar with PyTest, all of the test fixtures are placed in conftest.py. So just from reading this, I can see that in the bottom of this slide, an object is being passed into httpbin, and then it also returns a function. So just reading from this, I'm a little bit confused about what it's doing. So what are my next two steps? I can try to look up the keyword httpbin in the documentation. I can set some breakpoints and figure out what's going on with that method. So let's do that. I type in the words httpbin inside of the search bar of the request documentation website. I get some search results, and eventually I go and find this GitHub page. It's called httpbin, and it's a standalone API service that's publicly hosted. This particular service is written and run by Kenneth Reese, who's also the creator of the request library. And this httpbin.org supports a number of endpoints, including get, post, put, delete. So I'm going to try out some of the endpoints. This is the result of the cookies endpoint. I get out a JSON response. Another is the result of the get endpoint. This is another JSON response. I can also do a post request on the post endpoint of this httpbin with a set of dictionary keys in the data dictionary. And then in response, I can see that this is the same dictionary that I got. OK, so I'm starting to understand what httpbin is doing. And when you look at test request.py, httpbin is pretty much almost everywhere in a unit test, because every time a request is made in a test, you have to be able to compare it to some known correct output. And that known correct output is provided by httpbin. So this is a pretty big step in understanding how these unit tests are being constructed in the request repository. All right, so the next thing I want to understand is there's this variable called URL in the previous unit test that we saw. And we can drop a debugger inside. You can use the debugger of your choice. Some people prefer IPDB or PDB, and I personally prefer PDB++. One of my coworkers recommended that, so I pretty much just stuck with it. All right, so I put in a debugger right after the first request is done. And from there, I can inspect the URL, the auth object, the response. This is the resulting URL string, and it's digest_auth/user/pass. So I'm curious, what is this URL? And I go to my browser, and I type in this URL, as it says in the results, and then there's a pop-up that says I need to enter my username and password. And I know what the username and password is because that's given already in the unit test. It's user and pass. So I enter that, and I'm logged in. So I get this JSON response. This is the correct response. This is 200. All right, so that's pretty good. We're getting closer to understanding what this first line is all about, request.get. We looked at a unit test, so now we can look further on what happens next. So a request is being made to this URL, and I'm going to do yet another function definition dive and look at the get method and see how that's defined. So API.py is like the user interface for the entire request library. It's also where not only get methods are defined, but it's also where the post, delete, and all the HTTP methods are being defined. And that's how the developer interacts with the request library. So in this case, what's happening here in the last two lines of code is that there's this redirect value that gets set, and then a request is returned. And so I'm just going to go deeper into this code and really look at how this request method is being implemented. All right, this is the request method. There's a lot of doc strings here and some comments. And if you remove all the doc strings and the comments, this is really just 2 lines of code. A session context manager is being created, and then there's a request method on that session that gets invoked. So there's 2 questions here, and I keep asking myself more and more questions as I keep trying to figure out how does request.get get implemented. So my first question is, what is sessions? What is a sessions object? There's a mention of it in a unit test, now there's a mention of it here. And I'm curious about what is this request method that gets invoked inside of the session object. All right, so let's look at sessions. This is the class definition of sessions in sessions.py. You can't read it, that's fine. I can also look at the extensive and abundant documentation for the official request library, and it talks about sessions objects. That's really cool and convenient. So directly from the documentation, what is a session? So a session is an object that persists parameters across requests. It makes use of the urllib3's connection pooling. It has all methods that the request API has. And every time that you make a request of any sort, a new session instance gets created. The session also provides default data to the request object. So all of these are pretty much directly, almost word for word, from the documentation. All right, so I think we have an understanding of what the session object is doing and why it's needed. So let's figure out further, what is this request method inside of the session class? So here we go again, jumping deeper into the library. This is the request method inside of the session class. It looks daunting at first, but when reading it, I can break this up into 4 important sections. So first, there's a request that's created. There's a prop request object that also gets created. A request gets created, and then the response gets returned. So there's 4 steps to this. And let's go over briefly what these 4 steps are. First, a request object is created. Let's see how that's done. This is the class definition for request. And you probably can't see this, but I'll let you know that in the init method, there are a number of required arguments, including method, URL, headers, files, data, JSON, etc. So all of these are, most of them are parameters that you'll need to create a request. All right, so since that was pretty straightforward, the request gets created, and the second step is we use that previously created request, and then we make another object called a prepared request object, we call it prop in here. So let's figure out what this does. This is the prepare request method. A prepared request instance is made, and then prepare gets invoked on that instance. And prepare takes in a number of arguments, including like method, URL, files, and there's a number of arguments that is trying to, that's here. So there's also some arguments from the self object, which is the sessions object. And so prepare is merging these different request arguments to create a complete request object. All right, so we can go even deeper. This is the definition for prepared requests, and this is the method called prepare. And there's a lot more layers of abstraction. You can go even deeper to look at what prepare method is, or what prepare URL is, prepare headers, prepare cookies, prepare body, prepare off. But like, this can be your total rabbit hole. But I think we pretty much understand what prepare request is doing. It's combining a lot of different attributes to create a full request. So we can just move on to the next step in this process. So the next step is there's the request. It gets created, it gets sent, and then we have a response that gets returned. All right. To sum up, the requests get sent, and there's a send method that happens that it takes in a request object, and then the response object gets created. So I'm going to dive deeper and take a look at the send method, and it's a pretty long function, but like the important parts are are right in the middle of this function, where it talks about a thing called the adapter, and the adapter gets created, and then there's a send method on this adapter. So there's a lot more questions that are happening, and I'm diving deeper, like 5, 6 layers deep into the request library. All right, so I want to know now, what is this adapter object, and why do we need that? So this is the answer. So the adapter provides a way for the request library to talk to HTTP and HTTPS using the powerful urllib3 library. And this is directly from the request documentation. There's even more information about the HTTP adapter class in the doc strings. So we're finally getting to the part where, like 6 layers deep, finally, we're seeing the underlying machinery for how the Python request library is powered, and that's using urllib3. And at the top of this file, adapters.py, we see a lot of different urllib3 packages are being imported. So to go back to what the send method is doing from previously, we can go even deeper and look at the send method. And there's a lot going on here. And the send method makes use of many different urllib3 functionality to be able to create a response from it. So I'm curious about what this send method is doing and what like the final output is. So I place a breakpoint right before the return statement happens to see what the response is. And I run the same unit test on the command line, so that way I only get the results for that test. So this is the shell for looking at the different variables. So the breakpoint stops on this line in the send method, and I can inspect the URL. And that's pretty much what I expected. It's digest off/user/pass. Cool, okay, that's the URL that I've been looking at this entire time. Great. So the next step is I'll look at the response, and it looks like the response is, in fact, a urllib3 type of response. Okay, cool, that's also what I expect. The next step is that I invoke the build response method, which takes in the request and the response object, and I get this response back. And that's cool, because I can look at the attributes of this response. I look at the JSON data. I can look at the status code and a bunch of other attributes. And so this is finally when you have the response. It's finally made. So finally, OK, 30 or so minutes later, we have the response from this request.get. Cool. All right, how did we get to this point to figure out how request.get is implemented? We looked at a unit test. We looked at the get method. We looked at the request method. Then we looked at the sessions. And then we looked at the request method inside of the sessions, which has different, it's doing 4 different things here. And it might be a bit easier to look at a map of all the different files and the different methods and class names that are getting invoked to kind of keep your mind straight on what's going on. So everybody reads codebase, the same codebase, a little bit differently. So there's no one right or correct way to read a codebase. One alternative thing that I could have done is to entirely skip the unit test and instead place a breakpoint directly in the adapters.py, and then I can fire up a Python shell, make a request of any kind, and then hit this breakpoint. And then in the debugger, I can take a look at the variables and see how the response gets constructed. So there's different ways for walking through a codebase. All right, so we finally figured out what request.get is doing, and we looked at the unit test, we looked at doc strings, we looked at documentation, we set breakpoints. That's pretty cool. And we're lucky that the request library has a lot of really well commented code and doc strings and a lot of documentation about different parts of the library. But sometimes, you might get stuck, like figuring out what's going on for a code base that may not have all these different, like, full comprehensive unit tests and full documentation. So I think the best idea, if you get pretty stuck in general, is to talk to the core developers or talk to the maintainers. And the first point of contact would be like either if they have a mailing list or an IRC channel, you can ask some questions there. Alternatively, you can also do a get blame to see which person made that line change and get to look at the history of the code base to figure this out. And if you're stuck on a code and you want to figure out what it's doing, you can use your favorite Python shell and debugger and take a look at a smaller sample of the code base and go from there. So overall, this has been my perspective and my thought process for when I was first reading the Python request library. And things I've discovered and roadblocks and so forth. And I'm generally pretty curious about what other people's perspectives are in looking at different types of code bases and trying to see other people's perspectives and how do they figure these things out and how do they glue all these pieces together. So for people who are, say, avid users of a project, or for a maintainer of a project, I definitely recommend, say, you go and write blog posts or give talks and about how some feature is implemented in the code base that you're familiar with. And I think that a lot of people would be pretty curious to learn more about it. Right. And that's pretty much all I have. I'm happy to learn more about different strategies that have worked for you when you're reading a new code base. And this is something I'd love to talk more about. I'm in the hallways. I'm also on Twitter. Thank you.
We have time for some questions. Any questions for Susan?
Out of curiosity, when do you go through this exercise for another code base? Is it when you're implementing a feature and you're stuck, and then you'll stop and you'll take a couple hours to understand the implementation of something you're using? Or is this just something you do as a standalone thing for fun? Or is it when you're contributing to a new project?
I think really all of the above. I think for me, when I'm looking at other people's code, I usually already have a task assigned to me, or there's a project I'm doing that requires me to look at upstream code, like the Python request library or other code bases. So I think the answer is yeah, for all of the above. You can do it for fun too, if you want to.
Other questions?
I feel like here with requests, you kind of zeroed right into the core function like get and walked us through a lot of the big ones. But if you're just going to go into unit tests, there's an equally likely chance you'll pick something mundane and boring and not really central to the library initially. So any tips on how to get straight to the good, meaningful ones?
I think that's if you can find a unit test that maybe that covers that particular feature you're looking at, then that would be the first thing I would go to personally. But I think it's a lot harder when there's a lack of unit tests, or there's incomplete code coverage, and then you'll have to go directly and figure out what the code pathway is and place debuggers and see what's triggering which part of the code.
Other questions? Well, please help me thank Susan for her wonderful talk.
Thank you.